This demo deals with Newton's laws of motion. That's kind of an odd name for Newton's three laws because the laws seem to all deal with force, whether there is a force or not, and how the forces work. So for example, the first law is that when there is no force, things can move in a straight line at constant speed, or they can even sit still. So Newton's first law is about the natural state of things in the absence of a force. The second law, F equals ma, is a very famous expression. F is the force, m is the mass or inertia, a is the acceleration. It's really the response. Acceleration is how speed, velocity changes, either not traveling a straight line or changing speed. And then the third law is this business about action-reaction. Forces come in pairs. For example, the Earth pulls on me because of gravity, but I also pull on the Earth as well. So that's a force pair. Well, this demo is illustrating the idea of the response. What I have here are several metal balls on strings. And so for example, if I were to move the others out of the way and just let one move a little bit, just perturb it away from sitting still, it would swing back and forth like a pendulum. But because the other balls are in the way, if I let it swing down, it hits a ball, which hits a neighbor, has a back reaction on the one that is moving initially, and then something happens at the end, something flies off, and it kind of goes back and forth. It's a little bit like a modified pendulum. But this is kind of fun to play with because you can ask some interesting questions. So for example, if I raise one ball and let it fall, and by the way, after several collisions, the whole thing just starts to move. There's friction in the system. So it's really the first couple hits that matter the most. Bam! One goes off the end, it comes back and pushes the original ball back again, and then the whole thing kind of settles down and moves back and forth. So what happens if I do two balls? Suppose I lift two balls, three are sitting still, they're the target. How many are going to fall off or get kicked off at the opposite end? Maybe just the one ball will go up higher, right? Let's find out. Now, two balls go flying off, two in and two out. In some sense, the one in the middle is sort of always sitting still until the whole thing starts to shake. But normally it gets hit and hits the others and back and forth. Now, suppose I move three balls. What happens? Two are sitting still, three are coming in. So three go off on either end, right? Oddly enough now, whereas before with two balls, the middle one kind of always sat still. With three balls, the middle one never sits still. There's more going on here than just Newton's laws, but they're an important part of it. There are things having to do with energy as well. Anyway, that's just an illustration of the response, that with a force, there is a consequence. There's this business of acceleration from these forces, which means change in motion.